Hey guys, how's it going? I was gifted this FMK smart meter, smart multimeter. The model number is FKM8016B. So we'll just give it a little run through on a couple things. It is a small guy, as you can see here, pretty small. Has a little spin dial, has the non-contact voltage. You can hold the button for the light. It also has a flashlight. Flashlight is here. Honestly, doesn't do very well. You also have a hold button. You have a select button, which will change it from AC to DC. Hey, that's a pretty good one. So this one will not do DC amperage. Stuck to doing AC only. Maybe what I'll do is I'll set up a test rig for that as well. So that's a huge negative. It doesn't do DC current. Inside the box, they just give you some basic plugs here. We'll hook those up. And it gives you, I believe it's a set of AAAs, the cheapest AAAs I've ever seen in my life, and a screwdriver, a little case, and a temperature probe. So we'll go ahead and test out these probes with some versus the fluke that we have here. So again, common is black. The other one, which has voltage, etc., is the red. Let's compare. All right, so we're back. All I did was hook up the different cables to be able to compare the 2 meters. We are currently in voltage DC. It's kind of hard to see there on camera, but it's a little DC. The reading is fairly low. They match, so pretty close. So we're going to go ahead and flip on our unit. It's showing 21.02 volts, so those match. We're going to go down to 7 here. We're at 7, so pretty good there on both. Well, we know the fluke is fine, but they match is my point. At 1 volt, we're reading the same. We'll go all the way up to 31. 31, we're reading basically the same number. Overall, the voltage reading's pretty good on this guy. Next up is just going to be checking some AC voltage. So turn your meter to the V with a squiggly line. Make sure it's in DC or AC. Okay, so as you can see here, we're reading 1225, 1225. I mean, it's similar. All right. Next up, we'll just use the non-contact voltage in CV. So like some of the others, you have to be pretty close in order for it to work. Okay, we're back. We're just gonna look at some of the readings. So we'll do a couple resistance. I have a couple different items here in an LED, such as an LED, a diode, and some capacitors. We'll see how it works. We'll compare that to the fluke. So I just added in our fluke. Simple to use. Go ahead and turn it down to ohms. You can turn the light if you'd like. We are set in ohms. If you want to change the mode, you hit select. So they have diode mode. They have continuity mode, which we can check continuity mode just by, right. And that's anything under 50 ohms. And that works there because this is a 10 ohm resistor. We're going to set it on, and it also has capacitance. We're going to set it on the resistance side. We're going to use some little clips that I have here just to make it a little simpler so I don't have to hold these things on. So it's calculating and it's showing about 10.2, 10.1. We're going to turn the fluke on resistance as well. And it's going to auto range as well. We'll take and use the same connectors, roughly 10.3. So it's a little bit different, but not too bad. There could be all kinds of little things that cause that. All right, so that's the 10 ohm resistor. We'll go ahead and try another one. I think I have. So the next one is just a 220 ohms. And I think the last one's a 2 megawatt. Or excuse me, 2 mega ohms, not 2 megawatts. So we'll do the same thing. We'll just hook up the little probe test, or the clip probe, and we'll test it with both meters. All right, first we will use the FKM. So we're reading 217.4. The fluke is reading 216.3, so that's about a 1 ohm difference. Okay, then the last one, like I said, we will test out is going to be, this is a 1 mega ohm, plus or minus 1%. Okay, first again with the FKM. We're showing 1 mega ohm. We're going to show the same thing on the fluke here. Usually when it's this high, there's not even a secondary count. We're showing 1 mega ohm. So basically the same there. Okay, next up, we're just going to check some capacitance. I have two different size capacitors. I believe this one's a 100 microfarads, and this one is 10 microfarads. So we're going to use the same probes again just to make it a little easier. So we're going to use the same probes just to make it a little easier. So just checking capacitance, we set it to capacitance. And this is the, I think 105, which is what we're seeing here. Let's see, 100. It's 100. So being off by 5 is not so bad. We'll check it on the fluke. Okay. Hit select. Reading 104, so pretty close overall. We'll move on to the second one. We're seeing 10.8, and this is roughly a 10. All right, we'll move on to the FKM, reading about 10.8. And as you can see here, it lit up. But it doesn't give any kind of voltage. All right, we'll look at the fluke. And as you can see here, it's much brighter. And I said earlier that I think that has to do with the fact that this only uses 2 AA's. Let's move on to a rectifier diode. Then as you see here, we have about a 4 voltage of about 0.588 versus 6.9. So it's a little difference there. Last up is just going to be doing temperature. So you have a little temperature plug. So black goes into common, red goes into the voltage, hertz, etc. Switcher mode to temperature, and that's about right. In my house right now, it's about 73 degrees, 74 degrees, so pretty good overall. I'm not going to review the AC current, mainly because I don't have my adapter to make it easier. Everything else seems to be pretty decently in line with what I expect. Personally, I would say it's a 4-star or so. So good at home. There's some other better ones that are cheaper. Thank you for viewing.